Today I'm talking about reflection symmetry of regular pyramids. Remember, regular pyramids have a regular shape as the base, regular polygon as the base, and the lateral faces are congruent isosceles triangles. Reflection symmetry in 3D involves cutting the shapes into two congruent halves using a plane. Think about taking a saw blade and cutting the shape in half. The saw blade cuts, or the planes that cut the shape in half, are what we count. So we count the number of planes of reflection symmetry. So how do we determine the number of planes of reflection symmetry that a regular pyramid has? As you've probably figured out, we look at the base shape. The number of lines of reflection symmetry that a base shape has determines the number of lines of reflection symmetry that a number of planes of reflection symmetry that a regular pyramid has. Using equations, if a regular pyramid has a base with n sides, then the pyramid has n planes of reflection symmetry. If a pyramid doesn't have a regular polygon as a base, it can still have reflection symmetry. So here are examples, two examples of a pyramid with a rectangular base. Now this one still has the apex centered over the base, so we can cut it in half, just like we can cut the rectangle into two congruent pieces using our lines of symmetry. We can cut the pyramid along those two lines of symmetry through the base and the apex and cut this into congruent pieces. So the base shape, the rectangle has two lines of symmetry, and the pyramid has two planes of reflection symmetry. Now, if the apex is not centered and it's oblique, then we can still have symmetry, but now we're down to one plane of symmetry in this rectangular pyramid, where it cuts through the base this direction and the apex. The apex is centered this side to this side, but not this side to this side, so we can still have our one plane of reflection symmetry. As a side note, again, we have the cone, which has infinitely many planes of reflection symmetry. Just like the base, the circle can be cut into infinitely many halves using lines of symmetry. The cone itself, going through the apex, can also be cut into infinitely many planes of reflection symmetry. All right, so let's go on and talk about our right prisms. So again, I can bring out my right prisms that have their base shapes being regular polygons, and our lateral faces are all rectangles, which makes them the right prisms. Right prisms always have one plane of reflection symmetry that cuts the shape in half horizontally. So you can always cut through this direction straight through to cut the shape in half if it's a right prism. Additionally, then, there will be our planes of symmetry that go through the bases, top and bottom bases. And again, the reflection symmetries that are possible with the base shapes will tell us the number of planes of reflection symmetry that we can use to cut through the prisms. So if you have a right prism where the base shape is a regular shape, you're going to have for an n-sided polygon on the base, you're going to have n planes of reflection symmetry that can cut through the bases, plus one that can cut horizontally, so you're going to have n plus 1 planes of reflection symmetry. Again, cubes are special because in addition to the ones that are horizontal and vertical, you can also have planes that cut through on all the faces, and you can have things that cut through diagonal through the lateral faces as well. So again, look at your textbook to see some of the special things that can happen additionally with the cubes. Okay, right prisms whose bases are not regular prisms or regular polygons can also have reflection symmetry. So again, let's look at our rectangular prism. This is a right rectangular prism, and its base shape is the rectangle. Again, because it's a right prism, it has this plane that cuts horizontally, but it also has the planes that cut through the two bases. So the base shape tells you you have your two planes of symmetry plus the one that's horizontal. Now, it's not just right prisms that have symmetry, but oblique prisms can also have symmetry. So if you look at the oblique prism here, while we can't cut it in half horizontally, we can cut it in half through the middle here, and it will cut in half and still have a plane of reflection symmetry. So oblique shapes still can have reflection symmetry. Finally, let's look again at the cylinder, which has the circle as the base on the top and the bottom. It also has, if it's a right cylinder, one plane of reflection symmetry that cuts across the center, but there are infinitely many that can cut through the two bases.